For applications above 600 degrees Celsius, we recommend thermocouples. Sounds easy, but there are some rules to consider too. Hi, I'm Dietmar. I'm Senior Application Engineer for Temperature Measurement at Endress & Hauser. I'm working in the business for some decades and I want to share my expertise with you. The thermocouple voltage is produced whenever two metals join together and this assembly is exposed to temperature gradient. So it matters if you have your thermocouple installation, how you get this very, very small voltage to the electronics. Because typically you are operate at high temperatures. So maybe you cannot place a transmitter directly. Because the transmitter is only good up to ambient temperatures of 85 degrees. And if your application is 1500, maybe also the environment is too hot. So this is the best solution, but not always possible. So another possibility is if you expand your thermocouple wires with plastic cable made of the same material, extension wires. So your type K thermocouple is connected to a type K extension wire and you place your transmitter somewhere safe and cool. But obviously, if you do this with platinum, this is not possible. Because nobody will pay for platinum cables or if they won't be in the plant for very long. So here you need to do something different and this is called compensation wires. They behave quite similar like the platinum material in a limited temperature range of the ambient. Not totally the same, but they are much, much cheaper because they are not made of platinum, they're made of a different material. So this compensation wires will make the accuracy of your temperature assembly lower. But there's no other option if the ambient conditions are too hot for placing the transmitter directly and the original thermocouple material is too expensive to make extension wires out of this. The accuracy of the thermocouple, similar to the RTD accuracy and tolerances, which you can see in a previous video, have also this funnel behavior. A little bit different, there's not only one point, there's a constant expectation in a lower temperature range, below 350 degrees something, and then this funnel is opening. So there's a class 2 and a class 1. For example, this class 1 at 1000 degrees Celsius would give an expectation of plus minus 4 degrees of the sensor itself, which is not too bad. If you would extrapolate the RTD behavior, it wouldn't be that much away. But this is what the theory says. If you go to the standard, and you can go look into the IEC standard or into the American standard, there's written something like this. All of the tolerance classes stated here or there in the graph are only valid for new wires, for new thermocouple wires. That means in the moment the thermocouple exposed to the process condition, the wires are not new any longer, and the tolerances, in this case plus minus 4 degrees, are not longer valid. So the standard doesn't give you any indication how the expectation of tolerance and accuracy is in your real process. We had a lot of talks about this, customers asking us, yeah, I had a thermocouple in my process for 2 years and it doesn't look very good, what can I do? And so we have examined this and we have seen much, much bigger deviations, but they are not new. It's not indicated in the standard what is the real accuracy in the process. So what can be expected? I found some literature around it and let's have a look on type K. If you expose type K for 3000 hours at 1200 degrees Celsius, the resulting mistake was 60 to 80 degrees minus. And 3,000 hours are only half a year in the process. So this can happen. And this is not because of bad quality of the sensor, it's based on the physics behind. And this is bloody dangerous because in the controlled loop, the controller does not know that the thermocouple is indicating wrong, so it will increase the gas. So in fact, your process is hotter than you think, and this is really bloody dangerous. In the next episode, we will see the theory behind why thermocouples do drift, and you have to be aware about this. Hope you like it. If yes, watch out for the next video of this series and leave us a comment, a like or share.